You see them everywhere, from crazy sci-fi weapons to the scanner at the supermarket, lasers. But what really is this incredibly focused, powerful beam of light? And how did a technology that was once called a solution looking for a problem end up completely changing, well, everything? Let's dive in.
You might think this is something out of a movie, but nope, this is real. It's a massive telescope using lasers to literally create fake stars in the sky. Why? To help us get a sharper view of the universe. A laser beam is just so pure, so controlled, that it can shoot for miles and stay razor thin. So what makes it so different from any other light? Well, we can push that same technology even further. This isn't some artist's drawing. This is a super detailed map of the moon's surface, and it was made by bouncing laser light off of it, all the way from orbit. That's the kind of mind-boggling precision we're talking about. But here's the wild part. For all that cosmic power, the exact same principle is at work inside this little guy, a component smaller than a penny. This is a laser diode. It's the heart of things like a Blu-ray player or a barcode scanner. So how can one technology be both huge and powerful and tiny and precise? It all comes down to the unique properties of laser light itself. Okay, think about a regular flashlight. The light it makes is, well, it's a mess. You've got all these different light waves, all jumbled up, out of sync, and spreading out all over the place. A laser is the exact opposite. First, it's coherent. That means all the light waves are marching in perfect step, like a disciplined army. Second, it's monochromatic. It's made of just one single pure color. And third, it's collimated, which is a fancy way of saying the beam stays incredibly narrow even over huge distances. Those three things, those are its superpowers. So how on earth does a laser actually do all that? Well, the biggest clue is hiding in plain sight. It's right there in the name, which isn't just a word, it's a blueprint for how it works. See, laser is actually an acronym. It stands for Light Amplification by Stimulated Emission of Radiation. Now, light amplification, that part makes sense. But the real magic, the quantum secret sauce, is that bit in the middle, stimulated emission. So here's the core idea, and it's awesome. Imagine you have an atom that's all energized and jittery. We call it excited. Now, if a particle of light, a photon, with just the right amount of energy happens to fly by, it stimulates that atom to release a second photon. And here's the kicker. This new photon is a perfect clone of the first one. Same energy, same direction, same timing. Just like that, one photon becomes two. Okay, so that one becomes two trick is cool, but how do you get a powerful beam out of it? Simple. You create a chain reaction. You put your excited atoms between two mirrors. A photon starts bouncing back and forth, and every time it passes an excited atom, it creates another clone. And then those clones create more clones. It's an avalanche of perfectly identical photons. That is the amplification part of laser. That quantum theory is the whole foundation. But, to actually turn that idea into a real machine, you need three key ingredients. First up, you need a gain medium. This is just some stuff full of atoms that you can get excited, like a special crystal or a certain kind of gas. Second, you need a pumping energy source. Think of it like a flash lamp, to zap those atoms and get them all energized. And third, you need an optical resonator. That's just our two mirrors, ready to trap the light and start that chain reaction. And this diagram really shows how it all fits together. The pump energizes the gain medium, the photons start bouncing between the mirrors, building up that avalanche of light. And since one of those mirrors lets a little bit of light through, you get a stream of that perfectly organized, coherent light escaping as the laser beam. There's a fantastic analogy for this. Think about that horrible screeching sound you get when a microphone gets too close to a speaker. That's a feedback loop. The sound gets amplified, goes back into the mic, gets amplified again, and you get that piercing noise. A laser is pretty much the same thing, just an optical feedback loop. It's creating a screech made of pure light. So building the first working laser back in 1960 was this huge scientific victory. But funny enough, once they built it, nobody was really sure what to do with it. And this quote just perfectly sums up the mood back then. Scientists had invented this completely new kind of light, this incredible tool, but there weren't any obvious jobs for it to do. It was this revolutionary piece of tech with no clear purpose. But oh boy, that did not last long. That solution started finding problems to solve, and it found them fast. By 1974, it was scanning your groceries at the checkout. In '78, it was playing movies on those giant laser discs. And by 1982, with the compact disc, the laser officially invaded millions of homes, changing music forever and really setting the stage for our digital world.
And this side-by-side really tells the story, doesn't it? You've got this tiny little diode that reads your CDs, and then you have these monster systems that are probing the atmosphere. It's an incredible range, but the basic physics behind them is exactly the same.
Today, it's actually hard to picture a world without them. Lasers are the backbone of the internet, shooting our data through fiber optic cables. They perform eye surgery, they cut through solid steel, they print our documents, and yeah, they even catch speeders on the highway. And if you want to talk about impact, just look at the numbers. In 2023 alone, the market for industrial lasers was worth almost $22 billion. That's a pretty long way for a so-called solution looking for a problem to come. But here's the thing. The story is nowhere near over. Researchers are constantly pushing the limits of what this technology can do. I mean, just look at this graph. It's incredible. The intensity, the sheer power we can pack into a focused laser beam has been growing exponentially since the day it was invented. We just keep finding ways to make them more and more powerful. And the research happening right now, it's verging on science fiction. You've got scientists working on white lasers that can produce any color you want. They're trying to use lasers to kickstart nuclear fusion for clean energy. They've even figured out how to make living cells act as microscopic lasers. I mean, come on, how cool is that? So, from a theoretical twinkle in Einstein's eye to a tool that touches almost every part of our modern lives, the laser has had an absolutely incredible journey. It just goes to show that sometimes the most world-changing solutions show up before we even know what problems we need to solve. Which really only leaves one question: what's next?